Good morning everyone. Today we are discussing about the work power energy. So we are discussing about the work power energy. So work is the basically work is the dot product of work is the dot product of force and displacement. Basically work is the dot product of force and displacement. So this is vector definition of the work. But basically, what is work means? Work is said to be done. Work is said to be done. Work is said to be done. If the point of application of the force, the point of application of the force, the point of application of the force displaces. If the point of application of the force displaces the body. Work is said to be done if the point of application of the force displaces the body in the direction of the force. In the direction of the force. Very simple. Suppose I have taken M is the mass of the body. Let us say that F is the force applied. Let us say that this is theta. This is S displacement. Now work done is equal to what is the component of the force that is causing the displacement? That is nothing but F cos theta into S. So this is F sin theta. This is F cos theta. So F cos theta into S. And sometimes the displacement is resolved. This is theta and this is F. So what is the angle between the displacement and the force? Theta. Here what is the angle between the force and the displacement? Again theta. So here I am resolving the F. So resolving F means I am getting F cos theta. F cos theta is in the direction of the displacement. Then work done is equal to F cos theta into S. So here angle between ds and F is also theta. Now here I am resolving ds cos theta. I resolve ds. The component in the direction of the force, the component of ds in the direction of the force is ds cos theta. Now what is work done? Work done is equal to F into ds cos theta. So I can resolve ds and also I can resolve theta. That depends on the situation. So basically work done is nothing but Fs cos theta, A bar dot B bar, AB cos theta. So work done, I said here I mentioned work done is nothing but the dot product. So work done is the dot product of force and displacement. Then work done is equal to, can I write it as F bar dot S bar, which is equal to Fs cos theta, where theta is angle between F bar and S bar. So depending on angle, work is three types. One is positive work, second one is negative work, and third one is zero work. There are three types of works. One is positive work, one is negative work, and third one is zero work. So basically, what is positive work? So positive work means if the theta, positive work, what is positive work? 0 less than theta less than pi by 2. If the theta range lies greater than less than or equal to 0 and less than pi by 2, that is 90 degrees. If the theta ranges from 0 to less than pi by 2, work is said to be positive. Because here cos theta is positive. So cos theta is positive. Work done is also positive. Okay. Now suppose if pi by 2 less than theta less than pi, then cos theta value is negative, then work done is negative. Work done is negative. Suppose M is the mass of the body. I applied the force in this direction. Displacement is in this direction. This angle is 120 degrees. Then what is work done? Work done is equal to F S cos 120. That is nothing but Fs cos 120 is minus 1 by 2 minus Fs by 2. This is negative because theta value is greater than 90 degrees. When theta value is greater than 90 degrees, cos theta value is negative. This is nothing but, I can write like this. This is S, this is F. Let I say that this is 120 degrees. And I can write it as this is 60 degrees. This is 60 degrees. So I can write it as, now here see, displacement is in this direction. F cos 60 is in this direction. So angle between F cos 60 and the displacement, both are in the opposite direction. Then work done is equal to minus F cos 60 into S. That is cos 60 1 by 2 into S, which is nothing but minus Fs by 2. So actually this is nothing but that. This is nothing but that. So when the quadrant is changing, I mean theta greater than 90 degrees means the quadrant, the vector is in the, this force vector is in the second quadrant. Now angle between them is greater than 90 degrees. When the angle between them is greater than 90 degrees, then automatically the work done will be negative. So if theta is equal to pi by 2 and work done is equal to, I can write it as Fs cos 90. What is Fs cos 90? Which is equal to 0. So work done is equal to 0. Work done is equal to 0 if theta is equal to pi by 2. So these are the three types of the work. Work is positive, work is negative, and work is 0. So suppose if I take example, there is a truck. This is truck. Truck is moving with 4 meter per second uniform velocity. Truck is moving with 4 meter per second uniform velocity. There is an inclined plane inside the truck. And on the inclined plane, there is a 1 kg block. The angle of inclination of the inclined plane is 37 degrees. Now first of all, the block is at rest with respect to the block is at rest with respect to truck. Find out the work done. Find out the work done by the friction. Find out the work done by the friction in t is equal to 2 seconds. This is my question. So the block is at rest with respect to the truck, and find out the work done by the friction in t equal to 2 seconds. We have to find out the work done in t equal to 2 seconds. So to find out the work done in t equal to 2 seconds, I said that here the inclined plane, from the frame of the truck, the block is at rest. So from the frame of the truck, the block is at rest. If I take the free body diagram of block, now listen here. Now this is inclined plane. This angle is 37 degrees. This is block. Block is 1 kg. Now can I say that along the plane there one force will act? That force is nothing but mg sin theta. And here theta is 37 degrees, mg sin 37. So for the block to be at rest, definitely there should be the friction. So definitely there should be the friction. So friction is acting in the opposite direction to mg sin 37. Because friction is balancing, then only the net force along the plane is equal to 0. Then the block is at the rest. So the block is at rest with respect to the truck frame. Means the friction is equal to mg sin 37. So now here Can I write directly? What is friction? Friction is equal to mg sin 37. Now F is equal to, this is truck frame, frame of truck. Truck is at rest, I mean inclined plane is at rest. F equal to mg sin 37. What is m? 1. What is g? 10. What is sin 37? 3 by 5. And can I write it as friction is equal to 6 Newton. So friction is equal to 6 Newton. We got the friction is 6 Newton. Now what we have to do? We have to find out the work done by the friction at t equal to 2 seconds. Now when I am observing this truck from the ground frame, see, when I am observing the truck from the ground frame, how can I say that here ground frame? The truck is moving horizontally. I mean the truck is moving in a x-axis straight line. Now this is 4 meter per second. What is the displacement? So displacement traveled by the truck, displacement of truck in t equal to 2 seconds. Displacement of truck in t equal to 2 seconds. That is nothing but 4 into 2, which is equal to 8 meters. So displacement of truck in t equal to 2 seconds is nothing but 8 meters. Now we have to find out the work done with the friction. Now if you see the angle between the friction and the block, see. Now this is inclined plane, this is block. The displacement is 8 meters in this direction. And when you are observing the force on the block, friction is acting in this direction. So friction is acting in this direction means, now this is 37 degrees. Now I can write this is also 37 degrees. This angle is nothing but 180 minus 37. So 180 minus 37. And we calculated friction from the truck frame. What is the friction? We got 6 Newton. Now here, what we are finding, we have to find out the work done by the friction. So displacement is 8 meters in this direction and 6 Newton is in this direction. So can I write it as work done is equal to, apply the formula. Work done is equal to Fs cos theta. Cos of 180 minus 37. Now what is F? F is 6. Displacement is 8. Cos 180 minus 37 minus cos 37. So minus 48. Cos 37 is nothing but 4 by 5. So minus 48 into 4 by 5 joule. Joule is nothing but SI unit of the work. So joule is SI unit of the work. So what is the work done? I mean the block is at rest with respect to the truck. Find out the work done by the friction in t equal to 2 seconds. And in t equal to 2 seconds, the truck has travelled 8 meters of the displacement. And I went to the truck frame. I went to the truck frame and the observer on the truck frame, and I calculated the force, and force I got that is equal to 6 Newton. And then I calculated the work done. So work done is equal to Fs cos 180 minus 37. And after simplifying, I got 48 into 4 by 5 joule. So I calculated the work done from the frame of ground. So now here I calculated the work done from the frame of the ground because the displacement from the ground frame is nothing but 8 meters. Suppose if I go to the truck frame, what is the displacement of the block with respect to the truck frame? The displacement of the block with respect to the truck frame is equal to 0. That means there is no displacement with respect to the truck frame. So there is no displacement with respect to the truck frame means, then what can I conclude? Now can I say that work done V is equal to 0 with respect to the truck frame. So with respect to the truck frame, displacement is equal to 0. Then I can write it as with respect to the truck frame, displacement is equal to 0. Therefore, work done is also equal to 0. So work done is equal to 0 with respect to the truck frame, and work done is equal to minus 48 into 4 by 5 joule with respect to the ground frame. And here you can understand that work done is also depending on the frame of reference. And from this illustration, you can also get the idea that work done is depending on the frame of reference. Okay. So work done depends on the frame of reference. Suppose if the force is if the force is constant. For example, F bar is equal to 2I cap plus 3J cap plus 2K cap. Displaces the body through I cap plus J cap. Then what is the work done? And very simple, you can do the dot product. Work done is equal to 2 plus 3, that is equal to 5 Joule. So this is nothing but 5 Joule. Now here force is constant, displacement is also constant. Now suppose if I take for the variable force. So variable force means displacement is the function of x. Force is the function of x. Suppose force is the function of position. Force is the function of position means, let I say that x square plus 2x I cap. This is nothing but the force. So force is equal to x square plus 2x I cap, and find out the work done. Find out the work done from 0, 0 to find out the force work done from 0, 0 to, I can write it as, find out the work done from x only, 2 meters to 5 meters. Okay. Now can I say that here this is the variable work. So first of all, this is the variable work, and if you take the coordinates, I can write it as 2, 0 to 5, 0. This is variable work. So whenever you are getting the variable force, here work is said to be done by the variable force. Directly don't apply the formula. You can apply the formula, but there is little bit. So here displacement. What is displacement? Let I say that here displacement is equal to, I can write it as ds bar. Ds bar is the displacement. So ds bar can be written as in terms of I cap and j cap. So dx I cap plus dy j cap plus dz k cap. And here there is only I cap, that means the force is varying only in the x direction, and no need of j cap and k cap. Then can I write it as work done? Work done is equal to F bar dot ds bar. So what is F bar? X square plus 2x I cap. Dot what is dx bar? That is nothing but dx I cap. Now x square dx. Now I can write it as x square dx plus, let I say that this is dw because small displacement, x square dx plus 2x dx. Integration of dw. Integration of dw equal to work done. And can I write it as it is 2 to 5, and this is 2 to 5. So I can write it as 2 to 5, x square dx. X square dx is x cube by 3, upper limit 5, lower limit 2, and 2 of x square by 2, upper limit 5, lower limit 2. Now on solving, what we will get? Suppose work done is equal to x cube, that is nothing but 5 cube. So I can write it as 1 by 3, 5 cube minus 2 cube plus 2 into 2 by 2, x square by 2, 2 cancel, that is nothing but 5 square minus 2 square, and if you simplify, you will get the work done. So you have to find out the work done with the variable force, and this is the approach to find out the work done with the variable force. And suppose I can write it as, now here work is said to be done by the variable force. Force is the function of position. Now suppose one more example. If F bar is equal to x I cap plus y j cap, or I can write it as y square j cap. Find out the work done. In displacing. 0, 0 to 4 comma 6. So find out the work done in displacing 0 comma 0 to 4 comma 6. Now first of all, for the variable force, write it as ds bar is equal to dxi cap plus dy j cap. Now what is work done? Work done is equal to f bar dot ds bar. This is dw, you write. So dw is equal to f bar dot ds bar is nothing but, I can write it as, what is f bar? F bar is nothing but xi cap y square j cap. Now write down dxi cap plus dy j cap. Now can I write it as x dx plus y square dy and integration. So what is x limit? 0 to 4. And what is y limit? Y limit is nothing but 0 to 6. Now integration of x dx, x square by 2. Upper limit is 4, lower limit is 0 for x. And y square dy, y cube by 3. Upper limit is how much? Upper limit is 6, lower limit is 0. And on substitution, you will get. Now this is nothing but the work done. So work done is equal to this. So x square means you substitute just 4 square, 1 by 2 of 4 square minus 0 square. So you can write like this. Work done is equal to 1 by 2 of 4 square minus 0 square plus 1 by 3 of 6 cube. Okay. So you can simplify like this into 16 plus 1 by 3 into 6 into 36. 2 ones to 8. That is nothing but 8 plus 3 ones 3. 32, 72. So that is nothing but 82. So you can solve the problems like this. Now here only x is changing. Here both x and y is changing. So here the position, the force is variable with respect to the x and with respect to the y. I mean force is changing along x axis and along y axis. And here force is changing only along the x axis. And whenever the variable work is set to, whenever you are getting the variable force, and compulsory you have to write the ds bar in terms of the dxi cap plus dy j cap. Okay, and this is the method. Suppose we have discussed about the work is the function of position. Suppose if the work is the function of time is given, if the work is the function of time is given. Suppose for example, the force is the function of time given. Sorry. Let I say that m is the mass of the body. Let I say that f is equal to some. If force is the function of time, let I say that m is the mass of the body. F is equal to t square is the force. Now if is the force, here if force is the function of time, find the work done in t is equal to 2 seconds. Find the work done in t equal to 2 seconds. Now this is variable force as a function of time. Can I write it as work done is equal to f into dx? Can I write it as work done is equal to f into dx by dt into dt? This can be written as f into dx by dt is equal to dt. Now bring v as the function of t. So to bring v as the function of t, I can write it as, now f is equal to ma. F is of t square, which is equal to dv by dt. Now can I write it as m into dv is equal to t square dt. Now dv is equal to integration of t square dt of 1 by m. I can write it as dv is equal to 1 by m t square dt. Now what is v? V is equal to 1 by m t square dt, that is nothing but t cube by 3. T square dt is t cube by 3. Now can I write it as work done? What is work done? F is equal to t square. See, F equal to t square. What is V? V can be written as 1 by t cube by 3 into dt. Then this can be written as 1 by 3 into t square into t3, t power 5 into dt. This can be written as 1 by 3 t power 5 dt. T power 5 dt means t power 6 by 6. This can be written as 1 by 18m t power 6. This is nothing but the work done. Suppose in the place of work done, in the place of t, if you substitute 2 seconds, you will get the answer. So 1 by 18, M he will give, suppose him, he will give some 2 kg, like 3 kg, and T is equal to 2 seconds. If you substitute 2 power 6, then you will get work done. So I can write it as, for example, if M is equal to, I am taking 2 kg, then 1 by IT into 2 is equal to T power 6. T power 6 means 2 power 6. What is 2 power 6? 1 by IT into 2 into 2 power 6. 2 power 5 is 32. 32 into 2 64. Now 2 ones are 2 36. 18 ones are 18 2s. So that is nothing but 2 joule. So work done is nothing but 2 joule. So I can write it as 1 by 18 into 2 to power 6. If I take mass equal to 2 kg, 1 by 18 into 2 into 64. That is nothing but 36 to the 64, which is equal to 2 joule. So this is the procedure. I given the two procedures to find out the work done. If it for the variable force. Variable force as a function of x. Variable as force as a function of time. So variable force as a function of position. Variable force as a function of time. So as a function of time, you have to solve the problems like this. Okay. Now suppose, see here, we'll discuss few questions. Suppose I have taken the 2 block system. Let us say that this is 3 kg, this is 2 kg. Now here 3 kg is on the ground and here coefficient of friction is 0. And here mu is equal to 0. Let 50 Newton force is acting on the system. Now here I can take mu is equal to 0.5. Now my question is, find out the work done. Find out the work done by the friction. Find out the work done by the friction on 2 kg and 3 kg. Find out the work done by the friction on 2 kg and 3 kg. In T is equal to 2 seconds. D is equal to 2 seconds. Now we have to find out the work done by the friction on 2 kg and 3 kg. Initially, the system starts from rest. So first of all, for the block and block, always we have to go with the assumption that the 2 blocks are moving with the common acceleration. So first of all, you have to assume, what is my assumption? Assumption, 2 blocks are moving. 2 blocks are moving with the common acceleration. So 2 blocks are moving with common acceleration. Now can I write it as, for single system, 50 is equal to 3 plus 2, 5, 5a. Now acceleration is equal to 10 meter per second square. Acceleration is equal to 10 meter per second square. Or simply suppose, if I take 10 Newton, acceleration is equal to 2 meter per second square. Acceleration equal to 2 meter per second square. So 2 blocks are moving with common acceleration. This is my assumption. And first of all, I want to check the assumption. To check the assumption, first of all, I am taking my frame on 3 kg. So keep the 3 kg at rest. And take your position on 2 kg, 3 kg. Suppose this is my position. If 2 blocks are moving with the common acceleration, with respect to 3 kg, 2 kg will be in the state of rest. With respect to 2 kg, 3 kg will also be in the state of rest. Relative to each other. So there is no relative slipping between 2 kg and 3 kg. So if there is no relative slipping between 2 kg and 3 kg, means suppose if this is my position, when I am observing this 2 kg block, it will be at the rest. So it will be at the rest means, can I say that this is the non-inertial frame of reference? Take the pseudo force. Now can I say that here what is pseudo force? Acceleration is equal to 2 meter per second square. And what is pseudo force? Pseudo force is equal to ma. Mass of the body is how much? 2. And what is the system frame? 2. So 2 into 2. That is equal to 4. So now can I write it as, this is nothing but the 4 Newton. Now come on, check the availability of friction. So pseudo, F pseudo is how much? F pseudo is equal to 4 Newton. And what is this? Availability friction. So F available friction, which is equal to mu L, which is equal to mu is how much? 0.5 into normal force. Normal force is 20 mg 2 into 10. Now can I say that this is nothing but the 10 Newton? Now how much force is required? I mean, what is the maximum force of the friction is there? F max. Actually, F is less than or is equal to 10 Newton. What is F max? F max is equal to 10 Newton. And what is the required friction for me? What is the required friction for me? That is nothing but M, which is equal to, can I write it as 4 Newton? So required friction is nothing but 4 Newton, available friction, maximum friction I have 10 Newton. Then can I say that obviously it will become the self-adjusting. So it is becoming self-adjusting means, now can I say that on this 2 kg, friction is how much? Friction is acting like this, 4 Newton, because self-adjusting, actual friction is 10 Newton, but it is becoming self. So here friction direction is like this, and here action and reaction, friction direction is like this. So here 4 Newton force is acting, here 4 Newton friction is acting. So therefore there is no relative shifting each other. Now what we have to find? We have to find out the work done. We have to find out the work done if the system is dragged from the rest. Now can I write it as, first of all, we got the acceleration of the system. Now can I write it as s equal to ut plus half ut square, and as u is equal to 0, I can write ut is 0. Now s equal to half into, what is acceleration? Acceleration is equal to 2 into what is time? 2 into 2. So that is nothing but 4 meters. Now what we have to find? We have to find out the work done by the friction. So to find out the work done by the friction, now see here on 2 kg block, I am taking the work done by the friction on 2 kg block. Now let us say that this is 2 kg block, and from the ground frame when I am observing, now can I write it as this is 4 Newton acting in this direction, and 4 Newton of the friction is acting in this direction from the ground frame. There is no pseudo force from the ground frame, because pseudo force will be only comes through non-inertial frame of reference, and displacement is equal to 4 meters. Now work done by the friction. So work done by the friction is equal to 4 into 4, which is equal to 16 joule. And what is the work done by the friction on 3 kg? Displacement of the 3 kg is 4 meters, because they are united, they are moving with the single system, and force is nothing but how much? 4 Newton. Now can I say that here work done by the friction on 3 kg is equal to minus 4 into 4 opposite direction, that is 16 joule. So work done by the force on 2 kg is 16 joules, and work done by the friction on 3 kg is equal to minus 16 joules. Work done by the friction on system. Work done by the friction on system. That is which friction? Static friction. So work done by the static friction on the system is equal to 16 joule minus 16 joule. So that's it. Then work done by the static friction on the system will be always equal to 0. So work done by the static friction, work done by the static friction on the system is always equal to 0. Okay. So let us discuss few questions. Few identity-based questions we will discuss. Suppose now few questions, few typical questions we will discuss. First of all, example, if f bar is equal to, I can write it as minus k of yi cap plus xj cap. Now find out the work done. Find out the work done from, find out the work done. Okay, so find out the work done in moving 0, 0 to a, 0, then a, 0 to a, a. So this is the question. Find out the work done in moving 0, 0 to a, 0, then a, 0 to a, a. So continuously the force is acting minus ky cap plus xj cap. So find out the work done in moving 0, comma 0 to a comma 0. Suppose see here, so first of all, if I am taking like this is the position of the ball. Let I say that this is 0, comma 0, then 0 I am taking. O I am taking. Let I say that this is A. So the particle is moving from O to A, and let us say that what are the coordinates of A? Coordinates of the A is nothing but A comma 0. Now this is nothing but O to A. So O to A, origin 0 comma 0, this is nothing but A comma 0. So this is particle is moving along the x-axis. When the particle is moving along the x-axis, now what is the y coordinate? Y coordinate is equal to 0. So can I say that what is the displacement in this direction? Can I say that the displacement in this direction is nothing but dx I can? The displacement in this direction is nothing but the dx I can. So dx I can, and this is nothing but a comma 0 dx I can. Now what is work done? Now can I write it as work done is equal to f bar dot ds bar. F bar dot ds bar. The particle is moving along the x-axis. Then I can write it as minus k of yi cap plus xj cap, as the particle is moving along the x-axis from O to A. I am writing I cap. Now minus k of what is y coordinate? Y coordinate is 0. Y coordinate is not changing, so 0 plus of. Now can I write it as minus k xj cap? I can write it as dot dx I can. Now I dot j is equal to again 0. So work done from O to A, work done from O to A is equal to 0 joules. Work done from O to A equal to 0 joules. So after moving from 0 comma 0 to A comma 0, the particle has moved from A comma 0 to A comma A. So A comma 0 to A comma A. This is A comma 0, this is A comma A. I am taking the point as B. So A comma 0 to A comma A. So A comma 0 to A comma A, I am taking this is point B, this is nothing but the point A. So work done from A to B, I am calculating. Work done from A to B. Work done from A to B. What is this displacement? Y displacement, which is equal to dyj cap. Now can I write it as minus k yi cap plus xj cap dot dyj cap. Now can I write it as minus k? What is y coordinate in this direction? See, this is A, this is A. I mean A is not changing, x coordinate is not changing. So keeping the x coordinate constant, y is variable, that is nothing but 0 to A. So x is constant, keeping the x constant, y coordinates are changing. That means force is changing in the y direction. So force is changing in the y direction means this is nothing but yi cap. What is x coordinate? X coordinate is equal to aj cap into dyj cap. Now I can write it as minus k y I dot dy. I mean y dy I dot j plus minus ka dy j dot j. So I dot j is equal to 0. I dot j dot product is 0. So this will become 0. So minus ka. Now can I write it as dy. So this is nothing but dw from A to B. Now integrate. dw from A to B is equal to minus ka integration of dy. And if you see the integration of dy, force is changing from, it is changing from 0 to A. So see, coordinates are changing from 0 to A. Now can I say that this is nothing but 0 to A. Now therefore, can I write it as work done from A to B? So work done from A to B is equal to, can I write it as minus K into A, which is equal to minus K square. So now what is the total work done? Total work done is nothing but work done from 0 to A and work done from A to B. So total work done, WD total is equal to work done from O to A plus work done from A to B. So work done from O to A is 0 joules plus minus Ka square. So answer is equal to minus Ka square. And this is nothing but the work done by the variable force. See here, F is equal to minus K yi cap plus xj cap. Find out the work done in moving from 0 comma 0 to A comma 0, then A comma 0 to A comma A. 0 comma 0 to A comma 0, the particle is moving along the x-axis because y coordinate is 0. I wrote f bar dot ds bar minus what is f bar minus k yi cap plus xj cap, that is nothing but dx I cap, displacement is along the x-axis. And what is y coordinate along this? Here 0, here also 0. So y coordinate is 0, then I get y coordinate 0. and j cap dot I cap is nothing but 0. And when I am coming to A to B, keeping the x coordinate constant, that is A and A. Now what is varying? Y coordinate is varying. So x coordinate is A, y coordinate is varying 0 to A. So minus ky I cap A j cap. So in the place of x coordinate I replaced with A, then y is changing from 0 to A. So after finding the, then I got work done is equal to minus ka square. And this is the good problem actually. Okay. Now suppose one more problem we will discuss. One more problem. Suppose if f bar is equal to 3xy I cap. Suppose example. If f bar is equal to, if f bar is equal to 3xy I cap. Now find out the force from 0 comma 0 to find out the work done. Find out the work done. Find out the work done from 0 comma 4 to, find out the work done from 0 comma 4 to 2 comma 4. So we have to find out the work done from 0 comma 4 to 2 comma 4. So now suppose see, this is point. Now this is 0 comma 4. So this is 0 comma 4. What is y coordinate? Y coordinate is equal to 4 and x coordinate is equal to 0. So 0 comma 4 to 2 comma 0. 2 comma 4 and the y coordinate is fixed. So y coordinate is fixed. This is 2 comma 4. That means 0 to 2 x coordinate is changing. X coordinate is changing means here force is variable along the x direction. In the previous example, here force is variable in the y direction. So here force is variable is in the x direction. As force is variable is in the x direction. Now listen here. Force is variable is in the x direction. I can write this is displacement is nothing but dx I can. So force is variable in x direction and y coordinate is constant. What is y coordinate? 4. Then can I write it as f bar is equal to 3x substitute y. Y coordinate is nothing but 4. That is nothing but 12x I can. So force is variable in the x direction. That is how much force, which is equal to 12x I can. Now here we have to find the work done. So to find out the work done, how we will find out the work done? So to find out the work done, now listen here, to find out the work done. So work done is equal to f bar dot dx bar. F bar dot dx bar, that is nothing but, what is f bar? 12x I can dot dx I can. That is nothing but 12x dx. Now can I write it as, this is nothing but dw. Come on, do integration. What is the variation of the x coordinate? 0 to 2. That is nothing but work done is equal to 12 into integration of x dx is nothing but x square by 2, 0 to 2. And that is 2 ones to 6. And lower upper limit is 2 square minus 0 square, which is equal to the 24 joule. So answer is 24 joule. If f bar is equal to 3xy I cap, find out the work done from 0 comma 4 to 2 comma 4. And 0 comma 4 to 2 comma 4. Here 0 to 2 only x coordinate is changing and y coordinate is constant. What is y coordinate? 4. And this is the procedure to solve the problem. And next, suppose if we ask that if the particle is moving from 2 comma 0 to 2 comma 4, 2 comma 0 to 2 comma 4. Suppose if the particle, he will ask that, suppose if f bar is equal to 3xy I cap, find out the work done from 2 comma 0 to 2 comma 4. So we have to find out the work done from 2 comma 0 to 2 comma 4. Now see here 2 comma 2 means, now can I write it as, this is, I am taking 2 comma 2 to 2 comma 4. So this is 2 comma 0 and this is nothing but 2 comma 4. So that means the particle is moving along the y-axis. Displacement along the y-axis is nothing but dy j cap. Let I say that this is origin 0 comma 0. So 2 comma 0 to 2 comma 4. This is nothing but dy j cap. Displacement is along the dy j cap. I mean y-axis, I wrote dy j cap. Suppose f bar, what is f bar? F bar is equal to 3xy I cap. So f bar is equal to 3 into, what is x coordinate? X coordinate is fixed into 2 y I cap. That is nothing but 6y I cap. So what is work done? Work done is equal to f bar dot ds bar. ds bar is nothing but I am writing f bar dot dy j cap. Now what is f bar? 6y I cap dot dy j cap. That is nothing but 6y dy I dot j. So what is I dot j? I dot j is equal to 0. So therefore, what is work done? Work done is equal to 0. So work done is equal to 0. So work done is equal to 0. And is 6 dy I dot j is equal to 0. Then work done is also equal to 0. Suppose in this problem, see here. Actually 2 comma 0 to 2 comma 4, 2 comma 0, 2 comma 4, 2 x coordinate. So what is this point? 2 comma 0, x coordinate is 0, 2 y coordinate is 0. 2 comma 4, 2 comma 4 means 2 to 2 comma 4. That means force is changing along the y direction. So force is variable along the y direction. F bar is equal to 3xy 3 into, what is x coordinate? X coordinate is fixed, that is constant 2, 3 into 2 y cap, that is 6y cap. So but actually it is I cap, it is j cap. So dot product of I dot j is equal to 0. So no need of again doing integration because I dot j already became 0. Now see the same question. Suppose if the problem is given like this. If displacement of the particle 0, find out the displacement of the particle. If the particle is moving along, suppose if the particle is moving along like this, 0 comma 0 to 2 comma 4, the particle is moving along like this, 0 comma 0 to 2 comma 4, and this is nothing but this particle. This equation of the line is y is equal to 2x. So equation of the line is nothing but y is equal to 2x. So we have to find out 0 comma 0 to 2 comma 4. Now to find out 0 comma 0 to 2 comma 4. Now let I say that this is 0 comma 0, and let I say that this is 2 comma 4. And let I say that suppose if I take the displacement, for example if I take this is ds, this is theta. Now can I write it as this is ds cos theta, and can I write it as this is ds sin theta. What is ds sin theta? I will write it as dy. What is dx cos theta? I will write it as dx. Now what we have to find? We have to find f bar is equal to 3xy. Find out the work done from 2 comma 0 to 2 comma 4. Now can I write it as ds cos theta? I am writing it as dx. Now work done is equal to, can I write it as 3xy cap dot dx I cap. Simple. So can I write it as work done is equal to dw is equal to, can I write it as 3y. Now can I write it as x dx. So 3y x dx, can I write it as 3y x dx. Now can I write it as y is equal to 2x. So y is equal to 2x, as y is equal to 2x. Then dw is equal to, can I write it as 3 2x into x dx. That is nothing but 6x square dx. So integration of dw is equal to integration of 6x square dx. Can you see the variation of the x coordinate 0 to 2. So 0 to 2. Now that is nothing but work done is equal to 6x cubed by 3x square dx. That is nothing but 0 to 2. 3 ones are 3 twos are. So 2 into 2 cube, that is nothing but 8 twos are 16 joule. So work done is equal to 16 joule. So this is only about the work done, and in the next video we will discuss about the work energy theorem and other applications. Okay, thank you very much.